What if I told you that a disease once believed to be irreversible, a condition that slowly steals movement, balance, and independence, might soon be reversed, not managed, not slowed, but repaired at its source? No lifelong medication, no invasive brain surgery, no symptom masking, just tiny particles thousands of times smaller than a human hair traveling into the brain and repairing damaged neurons from the inside out. This is not science fiction. This is real laboratory science. And it may be the most important breakthrough ever made in the fight against Parkinson's disease. Intro. Welcome to VibeVerse. Welcome back to VibeVerse, the home of smart, viral, daily content where cutting-edge science, futuristic medicine, and life-changing discoveries come together. If you love breakthroughs that make you say this could change millions of lives, hit subscribe and join the VibeVerse family. Because today, we're diving into a discovery that could completely redefine how humanity treats brain diseases, nanoparticles that may reverse Parkinson's disease itself. Fact 1. Why Parkinson's has always been so hard to treat. Parkinson's disease affects millions of people worldwide. It causes tremors, muscle stiffness, slow movement, and loss of coordination. At its core, Parkinson's happens when dopamine-producing neurons in the brain slowly die. And here's the brutal truth. Once those neurons are gone, medicine believed they were gone forever. That's why current treatments only reduce symptoms, temporarily boost dopamine, slow progression. They do not repair the brain. Until now, the brain is protected by something called the blood-brain barrier, a powerful biological filter that blocks most drugs from entering. This barrier protects us from toxins, but it also blocks treatments that could heal damaged neurons. For decades, scientists knew what needed to be fixed, they just couldn't reach it safely. That's where nanotechnology changed everything. Fact 3. What these nanoparticles actually are. Nanoparticles used in this breakthrough are engineered at the molecular level. They are small enough to cross the blood-brain barrier, designed to avoid immune rejection, programmed to target damaged neurons only instead of flooding the entire body with drugs. These particles act like guided repair units, delivering therapy directly where it's needed. Precision medicine at the scale of atoms. Fact 4. They don't mask symptoms. They repair damage. Here's the revolutionary part. These nanoparticles don't just replace dopamine. They stimulate neuron repair, reduce inflammation, and protect remaining brain cells from further degeneration. In lab studies, researchers observed improved motor function, reduced tremors, distortion of neural signaling. In other words, the brain began functioning normally again. Fact 5. Why this is a completely new medical approach. A traditional Parkinson's treatment asks, how do we help patients live with damage? This new approach asks, how do we undo the damage? That shift from management to repair is what makes this breakthrough historic. It suggests that neurodegenerative diseases are not necessarily permanent. Fact 6. Early results stun scientists in laboratory tests. Animals treated with these nanoparticles showed dramatic recovery compared to untreated groups. Neural circuits that were once silent began firing again. Movement returned. Coordination improved. Researchers describe the results as unexpectedly strong and beyond current treatment capabilities. For the first time, Parkinson's looked reversible. Fact 7. Fewer side effects. Greater safety because the nanoparticles deliver therapy only to affected neurons. The rest of the body remains largely untouched. That means fewer side effects, lower toxicity, reduced long-term complications. Just targeted delivery could replace treatments that currently cause nausea, fatigue, hallucinations, and cardiovascular stress. Healing without harming. Fact 8. This could change more than Parkinson's. The implications go far beyond one disease. Scientists believe similar nanoparticle systems could be adapted for Alzheimer's disease, multiple sclerosis, traumatic brain injury, stroke recovery. For conditions once considered irreversible, this technology opens a door that medicine never had before. Fact 9. The brain may be more repairable than we thought. For decades, Neuroscience believed adult brains could not regenerate significantly. This research suggests the opposite. Given the right tools, the brain may be capable of self-repair. Nanoparticles don't replace the brain, they activate its ability to heal. Fact 10. Why scientists are being cautiously optimistic. This research is still in controlled testing stages. Human trials take time. Safety must be proven. But unlike hype-driven miracle cures, this breakthrough is mechanism-based, and grounded hope backed by real data. Conclusion: a new era for brain science for generations. Parkinson's med decline. Tiny nanoparticles invisible to the eye could soon give millions of people their movement, independence, and dignity back. This isn't just a medical breakthrough. It's a statement about what science can do when innovation meets compassion. If this discovery inspired you, like, comment, and subscribe to VibeVerse, where we bring you smart, viral, daily stories shaping the future of humanity. Because sometimes, the smallest things create the biggest hope.